Good morning.
All right. Y'all see the Sharpie right there? Yes or no?
Yes.
It's readable, right? Okay. That must be okay then. All right. So I'm gonna do today. Let's see. Today I'm gonna do number 19, number 22. Test number 2. All right, 19 and 22. And test number 2. All right. So before I do those, let me do O1 first. O. Yeah. All right. So we did this one here. Monday, we did those. 2 to the x equals 8. And the way I told you to do them on Monday was go 2, 3, 5, 7, 11, so on. So you start with 8. 2 divides 8, 4. 2 divides that, 2, 1. So 8 is 2, 2, 2. 8 is 2 to the 3 power. So you go 2 to the x, goes 2 to the 3. And 2 to the x and 2 to the 3. Cancel these guys out. So x must be 3. Okay, is that okay for the Monday one? If it's easy numbers like that, 2 to what number is 8? You can find it pretty fast. Does that make sense? Give me, put a big number. Not big number, bigger. How about this? 81. 3 to what is 81? All right. So 81, you go 3 divides 81, 27. 3 divides that, 9. 3 divides that, 3. 3 divides that, 1. So it looks like 81 is 3 times 3 times 3 times 3. So 81 is 3 to the 4. So 3 to the x equals 3 to the 4. So I know that 3 to the x is 3 to the 4. These are gone. So x must be 4. Is that right for that one and that one? Okay, I'm gonna do 2 more easy numbers. And then I'm gonna do numbers you get that you're gonna have to use your calculator. Okay. So I'm gonna try to get these two questions, that one, and that one today. I'm not sure how to do those in a little bit. All right. Number 2. Same kind of questions, but harder. So solve 2 to the x plus 1 is 32. So you're going to go prime numbers are 2, 3, 5, 7, 11, so on. So 32. So 2 divided 32, 16. 2 divided that 8. 2 divides that 4. 2 divides 4, 2. 2 divides that 1. So I have 1, 2, 3, 4, 5. So 32 is 1, 2, 3, 4, 5. 5. How many do I have? No. 1, 2, 3, 4, 5. There it is. I got it now. 2, 2, 2, 2, 2. So 2 times 2 is 4. 2 is 8. 2 is 16. 2 is 32. Yep. So 32 is 2 to the 5. That's what it is. So 2 to the x plus 1 equals 2 to the 5. So since the numbers are the same, then I can cancel the numbers. So x plus 1 is 5. So then you tell me the next step. Subtract 5 from both sides to get x.
-1.
Minus 1. So x must be a 4. Okay. That's okay. So now one more like this one. Then I'm going to do ones that you have to use your calculators. All right. One more like this. Suppose I have 3x minus 5 equals 9. Well, 3 to the x minus 5 equals 3 to the second power. Is that okay? 3 times 3 is 9. Now, that means that you can cancel one of these guys out. This is gone. X minus 5 is 2. So tell me that in the next step. What do you do to both sides?
Add 5.
Add 5, add 5. So the answer must be 7. 7 goes in there, it works out. All right. So now I'm going to go back to those formulas we did on Monday. All right. So now I'm going to go back to formula stuff. So on Monday, we did these things here. Ln of A plus ln of B equals ln of A times B. Ln of A minus ln of B equals ln of A over B. Ln of A to a power equals n ln of A. New one. Ln of E equals 1. Okay, so those are the old ones and the brand new one here in the bottom. Ln of E is 1. All right, so now I'm going to use these things. So now, this would be kind of like number, let's see. This would be like question, I guess like number 19, I guess. Well, anyway, let's just do this. If I say 2 to the x power is some big number, 19. There you go. 2 to what power is 19? Okay. All right. So now, problem is, if I go 2 to the power of 4, so if I go 1, 2, 3, 4 of those, I'm going to get 16. Okay. So 2 to the 4 power, that's too little. That's not 19. Okay. If I go 2 to the 5, that's going to be 1, 2, 3, 4, 5. 2 times 2 is 4, 2 is 8, 16, 32. 32, that's too much. So it's not a 4 and it's not a 5. It's 4 point something to get you the answer. So this is what we're going to do. You're going to do ln of the left side and ln of the right side. Step 1. I'm using this one here, number 3. The x power can go to the front. ln 19. So all I did is I put the power in the front. All right, so now to get the x by itself, I'm going to divide this side by ln of 2 and this side by ln of 2. So these are gone. So now you're going to have giant number. So now I'll show you how to do it. Ready? ln 19, you go like this. Look at my finger, not log, but ln. ln 19 divided by ln 2. Close it. ln 19, ln 2. Enter, get a bunch of decimal numbers. Give me your decimal numbers. What'd y'all get?
4.24792751 3.
79 what? 27?
2751 and then 3.
3. Okay. So 4.2479, all these other numbers. So now, to check this number, see if it works, you're going to have to do it like this. You have to go 2 to the power. Okay? You're going to go 2, power key, this thing right here. And then all these numbers here. 4.2479, 27513. Put all these numbers in there, hit enter. What did you all get?
18.99999.
Okay, let me write this down. Let's see. Okay. 2 to the power of 4.247927513. And you say you got 18.99999? 18 and a bunch of nines like this? Is that right?
Yes.
Okay. Or you can round it off. 18.99999 will be close to 19. Does that make sense for that?
Yes.
All right. So I'm going to do another one. Same kind of stuff. I just use a different number. Let's say instead of 2 to the x, I'm going to say 5 to the x equals 600. Okay. So step number 1, take the log of both sides, ln of this one, and ln of this number. So you have x ln of 5 equals ln of 600. So now I divide this side by something, this side by something. So ln of 5, ln of 5, these are gone. So x is giant number. I don't know what that is. Okay, let me do my calculator. Hang on. 600 divided by. Okay. All right, give me some numbers. What'd you get?
3.974635869.
Okay, so 3.97463, like that. All right, so now I'm going to go like this. 5 to the power of that number right there. 3.974635,869. And if you do it on the calculator, let me do it on my calculator. 5 to the power of. Okay. What'd you get?
600.0000003.
How many zeros?
6.
1, 2, 3, 4, 5, 6, like that. And then 3.
Yes. Yes.
Okay. So you go 5. Let me do it on my calculator. To the power of. Four. Again. 5 power. 4. Okay, that is 3. All right, so we do another one here. 3.97, 46, 35, 869. You check it one more time. Power, and I'm gonna change the numbers in a second. Point. Okay, got it. All right, let me go next one. Page number 4. Let me do a couple more like this. You'll see in a second. If the numbers are bigger, let's see. How about 5 to the x equals 626. 5 to the x equals 626. Same thing. ln of 5 to the x, ln of 626. So the x goes in front of 626. So now I need to divide both sides by, you tell me. What do you think it is? What goes here? What goes there?
Divided by ln 5.
Yep. And over here, ln 5. These are gone. So we have that number. Let's do it in a calculator. So I have ln 626 divided by ln 5. Okay. Give me your numbers.
4.000993341.
All right. So you got this number right here. So if I go 5 to the power of that number, 4.000993341. All right, do it in the calculator. So what you get? 5 power 4.123993341. What'd you get?
625.9999996.
Six nines like this? 1, 2, 3.
Yes.
Like that. Okay. So you said the end of 6. All right. So tens, hundreds, thousands, millions, trillions, gazillions of a penny, whatever. Yeah, it's like 26. Okay, we do one more like this, and then I'm gonna jump to I'm gonna do another one. Okay. All right. How about this one? 2 to the x equals 10, 20. I don't know. 23. Sounds good. 10, 23. So we're gonna take ln both sides, right? Just like the other one. ln of this number and ln of this number. We have x ln of 2 ln of 10, 23. So now divide by, you tell me.
Divided by ln of 2.
Right. ln of 2. These are gone. Calculator stuff. Then 10, 23 divided by ln of 2. All right, give me numbers.
9.998599043.
859043, like this?
Yeah.
Okay. All right. So then, and if I check it, 2 to the power of that number, 9.998599043. I don't know. I guess I'll do it on my calculator. You do it in yours. 2 to the power of 9.99. What'd you get?
1023.
exactly?
Yes.
Okay, so this one came out just the same number as that. All right, so that's page 4. We go to page 5. All right, ready? So now I'm gonna use this problem to show you how to do this. And I got this from all right. Okay, let's say your mom's birthday is gonna be happening soon. And you ask your mom, what do you want for your birthday, mom? So, well, I know what I want. She says, in the kitchen, I had that little tiny clock, a small little clock. I don't like it. I said, okay, well, what do you want? She goes, I want a giant clock. What do you have? She has a little clock like this, real small one, on top of the refrigerator. She says, I don't like that clock. Okay, what do you want? She says, in the kitchen, I want you to buy me this giant clock like this. Okay, and also, I want to make sure that it has real wood on it. Okay, not the plastic junk, but it's all wood. Around it is all wood. Okay, nice clock like that, big giant clock. Put it inside on the kitchen. What else do you want? She goes, that's all. I just want a clock for the kitchen. Okay, that's it. That's it. All right. So this is what you do. You follow Alto. Right away, you go to your favorite shopping place over there by 1604 and I-10. It's called La Cantera Shopping Mall. You know where that is? Like 40 miles north of here, 1604 out there. You go over there. And there they have all kinds of cool stuff at those stores. They have Saks Fifth Avenue. They have Prada, Gucci ones, Louis Vuittons. They have everything there. Okay. All right. So now, when you look at the clocks, they say this clock's right here, but it's a clock by these people. So if it's a Prada clock or a Gucci clock, they're gonna charge you a big chunk of money for that one clock, right? So you tell the guy, how much is the clock? He says, today it's only $2,800. You want to buy it? And you look at it, you go, I don't know. It has real wood in it, and it's a clock, and it's $2,800. So then you say, you know what? Nah, that's okay. Never mind. No, thank you. So right away, what you do is you go back to the south side. Okay, you go back to this place here. Morrison and 410. Okay, you come back to the south side. Morrison and 410. And I'll tell you what's there. It's called the Pulga or flea market. Okay. Question is, do they have a lot of stuff at the flea market?
Yeah.
Do they have all kinds of toasters and clocks and everything, right? Whatever you want, they have it. So you go down there, talk to the guy, look around, and say, "Hey, look, that guy has a bunch of clocks in his his flea market thing here." And you say, "Look, you see, look at one. This is what you do. You look at the clock in the flea market, and you look at it and say, okay, well, that's a nice big clock, and it has wood around it. Yep, real wood all the way around it. So like looks all brand new. So you look at the clock and you say, okay, right now it looks like it's saying that this is what it is. Okay, you look at your watch and say it matches that one. Yep, it looks exactly the same time. They're matching. All right, so now what you do is ask the guy, how much do you want for this clock? He's gonna tell you, well, it has real wood. I already fixed it. I already made it all not perfect. There's nothing wrong with it at all. And I want cash. I want $45 cash for it. If you got $45, you can have it. So no, it's kind of a lot of money. I don't know. Let me think about it. So that's what you do. So what you do is go walk around the flea market for a while. Okay. Look at that. Get ice cream, get raspas, whatever you want. Get tacos, whatever. You can shop at all the other places. Later, come back later. Okay. come back like at, I don't know, at 2:30 p.m. And come back again to this place. After at 2:30, everything's shutting down. At 2 o'clock, 3 o'clock, the flea market people start leaving. So you're there earlier. So now you go back at 2:30 and you tell that guy, how much do you want for that clock? He says, I want $45 for that clock. Then you say, well, my offer is this. I have $20.11. I have cash right now in my pocket. I have $20.11 cash. So you take $20.11 cash right now for that clock? Yes or no? And also, when you go back to that place to look at the clock, check it. Make sure that this clock here as it's moving matches your wristband also. So if your clock matches that one 3 hours later, is it working? Yes, it's working perfect. So you tell them this. And here's my question to you. If you offer the man $20.11 only, and it's already 2:30 in the afternoon and people are closing out shops, putting their junk away to leave, you think he'll take this cash? Yes or no? Or you think he's gonna put all the stuff back in his box and take it home in his truck? What do you think? Will he sell it to you? Yes or no? Guess. Yes, for sure. Yes. He's gonna say, you know what? I'll just get you a box. I'll get you a box and I'll put your clock in there and you can just take it home, okay? And tell your mom happy birthday. Okay. So you get the clock, and now this is what happens. We're gonna use the log functions in a second. All right. So now we're right here. All right. So now here's the clock. It's in the kitchen. Okay, you put it in the kitchen for your mom's birthday. So, and then your mom's birthday is Sunday or whenever it is. You told mom, "Hey, mom, I got your present." She says, "What do you have?" "What you told me to. You got the clock." It's it, and it has real wood on it, all the way around it, man. Real wood. Yep, real wood, not plastic. Okay. So now I'm gonna tell you what's gonna happen. When you buy stuff from the flea market, it's not brand new stuff. You know, you understand it, right? It's stuff that they got from somebody. They bought it from somebody's house, somebody's garage, somebody's estate sale. They got all that stuff somewhere, and then they clean it up, get it all ready, and then they sell it. So now, I don't know if you ever seen one of these, but I'm just gonna draw it. Let's see if you tell me if you've seen it or not. I just try to draw. Okay, little eyes right there. And they have little hands, and the long legs like this. The pelitos right here, the bolitas right here. Okay, you ever seen one of these? Okay, you probably never seen one before. This is what they're called. They're called roaches. Okay, and they live everywhere. So here's a question for you. Suppose you get the clock, you look at it, it's all nice and neat. If you flip this clock around, like this clock right here, if I flip it around, there's all this junk inside there, all this gears and junk. Okay, here, just a clock, and there's all this stuff inside. But this is a little clock. You got a giant one, big old monster clock in your mom's kitchen. In the back, there's all these gears and all these wires and stuff inside there. Also, is there a chance there might be two of these? What do you think? One male and one female?
Yeah.
Yeah, one male, one female, right? When these roach guys here, only one and one. But if they're in the kitchen at nighttime, do you think they're gonna come out and eat stuff at your kitchen?
Yeah.
And if you have dirty dishes and you have pizza on the table, you have sandia, watermelon, whatever, they'll eat whatever is there. It doesn't matter. They'll eat anything that you leave there. So now I got this from a biology book. I said, okay, if you start out with two of these, And you don't know they're there. And every night they're coming out and eating, and they go back in. Every night they come out eating. After a while, are there going to be more? Then after a while, are they going to move to your, are they going to go to the bedrooms, to the kitchens, that kitchen? They're going to go to the dining room. They're going to go everywhere. So eventually, I'm just going to give you the number I saw. Okay. That's what happens. You start with 2. And after so many weeks go by, you're going to have more. You're going to have 31,000 of these guys living upstairs, downstairs, in the kitchen, behind the refrigerator, the toasters, everywhere at your house, behind the walls. So now, the way you solve this one is you take the log of both sides. Is everybody okay right there? Step number 1, ln. And where does the x power go? I put in front like this. Then what? Divide by something. You tell me.
By 2.
Yeah, by 2, ln 2. Okay. This one by ln 2. And this one also by ln 2. Okay. Like this. Like that. So I know these are gone. So now, all right, do it on the calculator. I'm gonna do it on mine. You do it on yours, okay? ln, what is it? 31,000. And divided by ln of 2. Okay. What'd you get? Give me numbers.
14.9199806.
All right. So I guess like 15 weeks. All right. So what happens is in 15 weeks, instead of just having 2, 1, 2, you're going to have that many living at your house. But you don't know they're there. You don't know that they're multiplying, and 1 week later, 2 weeks later, 10 weeks later, 14 weeks later, almost 15 weeks later, you have all these population of these guys in there. Does that make sense? Now, you might see things like this. Let me show you something. Okay. Let's say this is the table in the kitchen. All right, there's a table in the kitchen. Okay, there it is. All right, so every day before you go to sleep, you do this. You clean everything up. You clean all the dishes, all the tables, all the tabletops, everything. Clean it, and then you put the dishes away. Everything's done. Then you go to sleep. But in the morning, when you wake up and you look at the table, you say, "What is this?" And you see, and I'll tell you, I'll just write this. You see little pieces of pepper on your table. Where do you think the pepper came from? Huh? Is it pepper or is it little bug things? You know where it came from. It came from this guy right here. They walk around, they leave their marks, they leave all their junk there. Because it's everywhere inside your house. There's 31,000 of these guys in there. Does that make sense? All right, so now I'm going to go to the next question. Okay. All right, so 2 to the x 31,000 after 14.999149 or 50 weeks. That's close enough. Now I'm going to do a different kind. Ready? Number 7. I'm going to say e to the x equals 19. All right, e to the x is 19. All right. And the formula that I gave you today, the new one is this one. ln of e equals 1. That's the format, the new one that we did today. So now, if I take ln of ex and ln of 19, it can be x ln of e equals ln of 19. So, and ln of e, see right here is 1, equals ln of 19. So x equals ln of 19. So now, calculator this number right here. ln 19 on your calculator. ln 19. Give me numbers.
2.944438979.
Like that? Okay. To check it, this is what you're gonna do. You're gonna go second ln. Okay, and I'll do it right now. Second ln. Second ln is this one right here, the ln, that one. You see the little e thing pop up? So you got e to the power, because it's up here somewhere. That number, 2.944438,979. So put that in the calculator. 2.944438,979. Oh, I got 19 exact. What'd you get?
19.
Exactly 19?
Yes.
Okay. All right, that's pretty good. All right, so now I'm gonna make it a little bit harder. Same problem. I'm gonna go e.10 equals, I don't know, 200. Okay, like this one, except it has a decimal point up here. Boom. So you're still gonna do this, ln of e 0.10x. You're still gonna do this, e to the 200 0.10x times ln of e, ln of 200. And I said that ln of e, this part right here is just a 1. That's the 1. Ln of 200. So 0.10x equals ln of 200. So now I'm going to have to divide this side by something and this side by something. What? You tell me. Divide by what?
0.10.
Yep. 0.10, 0.10. These are gone. So now, calculator time. ln 200 divided by 0.10. Give me a number. What'd you get?
52.9831737.
317,367, like that? 98,
Yes.
31, 7367. Okay. Now, to check it, let me just show you how to check it on this one. You're going to go second ln. You're going to go e to the power. It's going to go second ln. Second ln. And up here, you're going to put that number. You're going to put 0.10 times that long number, 52, 98, 31, 73, 67, close it. So put that in the, put in the calculator, so what'd you get? See what you get. What'd y'all get?
1.024000005E23.
No way. You got that? Wait, let me do it in mind. Okay. Second ln, and then you go parentheses. What's the number? 0.10, 0.10, parentheses,
Oh, she hasn't got that.
52.98, 317, 367. Close it, close it. I got 200.0000, a bunch of zeros. What you can do it again. Y'all get something like that? One, I guess. Yes or no? 200. Yes?
Yes.
Okay. So then that's okay. All right. Let me do another one. All right. Let's go back to. All right. Number 8. Yes. Yes. Grandma. 5 bedroom. 5 bath house. All right. Grandma's house. She bought her house long time ago. She probably paid like $50,000 for her house. Long time ago. But that's what she paid long time ago. $50,000 for a 5 bedroom, 5 bath, everything in it. Brand new. But as time goes on, her house will be worth more and more and more. Okay, it's kind of how it goes. So here's a question for you. Her house is worth $50,000 right now when she buys it, but later on, when her and grandpa get older and they're going to sell their house, they're probably going to get this much money for their house. So 50,000 years from now, after they buy their house, they can sell it for more money. So now, step 1, I'm going to divide both sides by 50,000. This one by 50,000, and this side by 50,000. Like that. These are gone. 0.10x. All right. So now 90000 divided by 50000. Do it in the calculator. Tell me what you get. Do it in the calculator. 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4 zeros. Oh no, whatever that is. Do it in the calculator. What's 9 5 zeros divided by 5 4 zeros?
18.
Exactly 18. Like that.
Yeah.
All right. So now I'm gonna do the same thing. ln of e to the 0.10 and ln of 18. So 0.10x ln of e equals ln of 18. And I told you that ln of e is always going to be a 1. So 0.10x times 1 equals ln of 18. So 0.10x equals ln of 18. So now divide by, you told me, what? What do I divide both sides by?
0.10x.
0.10, 0.10, like this. These are gone.
Yeah.
So x is, I don't know, some number. So they're going to be at their house for how many years? Give me a number. What'd you get?
28.90371758.
Okay, 371758. Like this?
Yes.
Okay. So here's the thing. So 29 years, 28, 29 years later, after they lived at that house, make sure they stay keeps in shape. They're gonna go from $50,000 house to $900,000 house. Does that make sense? And now, maybe one more like this one. Number 9. This one. Tuition at. All right. Right now, tuition at Palo Alto College. If you take 4 classes, Palo Alto, how much is tuition and fees? You think for that? Tuition and fees for 4 classes, like 12 hours. I don't know. Just guess. 1,000, 1,200. I don't know. What do you think it is? I'm just gonna guess. I'm gonna say it costs $1,200 to go for one semester. So 2 semesters would be 1,200, 1,200. It'd be $2,400 to go to Palo Alto for 2 semesters, second semester, for 1 year. Okay. All right. So 1 year, you're gonna have to pay $2,400. Okay, now if you don't want to go, this is a state school also. The state pays for a bunch of it. If you don't want to go there, you can go to a private university. Okay, like I'll give examples. St. Mary's is private. Our Lady Incarnate Word University, private. Our Lady of the Lake University, private. Trinity University, private. All these are private. That means Palo Alto, that's all they can charge because the state says, you know what, that's all you can charge for 2 semesters. 1,200, 200, or 2,400. But if you go to this other schools over here, the state cannot control them. They can do whatever, they can charge whatever they want to charge. Does that make sense?
Yes.
All right. So let's say you say you want to go, say really, nah, I don't want to go there. I want to go out of town. Let's go to a more expensive school. Let's go to Baylor. Okay. So for Baylor, I think for 1 year, I think it costs this much money. Last year, I don't know what it is this year, but it's like this much. Okay. If you want to go to Baylor, it costs $70,000 for 1 year. Okay, for fall spring. Okay, that's what it is right now. But and next year from now, does the tuition go up higher next year and the year after that? What do you think?
Yes.
Always, they always go up. So here's that. Let's set this one up. So right now, if you go today, if you go to Baylor right now, it's gonna cost you $70,000. If you wait, you say, you know what? I'm not gonna go. I'm gonna wait about 4 or 5 years, 6 years from now. Then I'll go to Baylor. Okay. Well, if you wait years from now, they're gonna charge you more money. Does that make sense? How much more?
Yeah.
Let's find out. So instead of 70, I say that in the future, if you call Baylor and tell them how much is your tuition now, I bet it's gonna be a gigantic number like this. Right now it's 70. Later on, they're gonna charge you like twice the price. They're gonna charge you 140. So let's solve this one. Step number 1, divide by 70,000 on both sides. And this one, same thing. Divide both sides by 70,000. Okay, so these are gone. So e to the 0.2x is, you tell me, what's 140,000 divided by 70,000. Give me a number.
2.
2. All right. So now I'm going to go ln of e to the 0.2 is ln of 2. So 0.2x times ln of e equals ln of 2. So 0.2x, and we said that ln of e is always 1 times 1 equals ln of 2. So 0.2x equals ln of 2. So 0.2x divided by 0.2 and ln of 2 divided by 0.2. So this is what happens. If right now it's 70, and how many years is it going to be twice the price? They're going to charge you $140,000 for that thing. So give me, I don't know, do it in the calculator. ln of 2 divided by 0.2. Okay, give me numbers.
3.465735903.
Like this.
Yes.
So like 3.5 years from now, if you call them 3.5 years from now, so how much is tuition now at Baylor? So right now it's $140,000 for 2 semesters. But we can get you a student loan. We can sign you a student loan if you want. You want to borrow money to go here. And then if you say yes, they'll sign your student loan for that. Does that make sense? Yeah. And then next year you sign up another loan, right? And next year after that, sign another loan, right?
Mm-hmm.
It's like 4 years in a row, sign loans. All right. So now these are all pluses. Make something gets bigger. Something gets bigger. Now I'm gonna make something that gets smaller. Okay. So number 10. All right. So now let's do it this way. So you buy a new car. Okay. And let's say you paid, I don't know, we'll just say this much money. Mom and dad get you a brand new car and it costs $40,000. All right. So now you bought you the brand new car, costs $40,000. So every year or every month, your car's gonna start dropping in price, lower and lower and lower and lower. Does that make sense? Eventually, that $40,000 car you have is only gonna be worth $10,000. So the question is, how many years does that happen before that happens? Okay, so now step number 1, divide by, you told me, by what?
40,000.
40,000. These are gone for sure. All right, so now on your calculator, you need to divide 10,000 by 40,000. Put it in the calculator though. I got decimal. What'd y'all get?
0.25.
Yeah, that's what I got. I got 0.25. Let me do it again, just to make sure. Yeah, I got the 25. All right, so let me write down what you just said. I got 0.25. Is everybody okay with that? 10,000 divided by 40,000. All right, so now you got 0.25. All right, so now ln of this side and ln of this side, so negative 0.4x times ln of e equals ln of 0.25, and then ln of e equals 1 formula. So negative 0.4x times 1, because there's an e right here, equals 0.25. So negative 0.4x equals ln of 25. So now I'll divide both sides by, you told me, what?
Negative.
Negative 0.4. And same thing over here, right? Negative 0.4. So x is years. Give me numbers. Let me do it on my machine. And then 0.25 divided by negative 0.4. What'd you get?
3.465735903.
So 3.46 like this. 3.4657. Yes. So I guess 3.5 years. You buy your car, and 3.5 years later, they only give you 10,000 for your car. That's all it's worth because it went down in price. Does that make sense?
Yep.
Yes. All right. So now that you have the scale, now we're gonna be able to do. We're gonna do exactly number. I'm gonna do exactly number 19. Okay. Number 19. Ready? Now it looks like this. It's 20 e negative 0.1x equals 2. That's what it is. E to 20 e to the negative 0.1x equals 2. All right. So now divide both sides by, you tell me. What do you think it is?
20.
20. and this one by 20, right? So e to the negative 0.1x equals, do it in calculator. What is that?
Point one.
0.1, like this? Is that okay? Okay, so now what do I do? Ln both sides?
Yes.
Ln of this number and ln of this number. So negative 0.1x times ln of e plus ln of 0.1. So negative 0.1x times 1, right? Remember, ln of e is 1. Ln of 0.1. So negative 0.1x equals ln of 0.1. So now I divide by what? You tell me.
Negative point one.
One there. By negative 0.1. So, I don't know. What is that? Give me numbers.
23.02585093.
0.258 5093. Like this.
Yes.
0.2585093. Okay. Yeah, that's right. That's what I got. I'll give you an example. Like if they give your grandma some painkiller, they give her this much painkiller. Then eventually the painkiller starts wearing off. Let's say her elbow's hurting or something. They give her a painkiller. But then in 23 minutes later, they're gonna tell you, you know what? This thing's gonna wear off, or maybe not 23 minutes. Let's say in 23 hours. They're gonna say, okay, we're gonna put this stuff on your elbow. It's gonna kill the pain. But in 23 hours from now, it's gonna go. The painkiller's only there's gonna be 2 of it left in there, and then you're gonna start feeling pain again. When you feel pain again, what are you gonna do? Get some more medicine on there. Does that make sense?
Yeah.
Put it on there, and then you put some more. You put some more. All right. So then that's number 19. Okay. So now I'm gonna go to number 22. Okay, so let me set up number 22. And then I think we should be okay. All right. 12. All right. Number 22. It says 2 to the x minus 2 equals 16. There it is. 2 to the x minus 2 is 16. This number, prime numbers. 2, 3, 5, 7, 11, 13, a bunch of numbers. So 16. Does 2 divide 16 how many times? You tell me.
8.
8. And does 2 divide 8? Give me a number.
4.
4. And does 2 divide 4?
2.
2. And 2 divides 2?
1.
1. So it looks like 16 is 1, 2, 3, 4. Or 16 is 2 to the power of 4. So 2 to the x minus 2 equals 2 to the power of 4. Does that make sense?
Yes.
And then, since I know that they're matching, can I just automatically kill these off like this? So x minus 2 must be 4. And then how do you do the next step? Add something.
Plus 2.
Plus 2. Plus 2 equal plus 2. So x must be what number?
6.
6. Okay. All right. Another one, same thing. 22.999. I'm going to say 5 to the x plus 1 equals 625. So I'm going to start with 625. I'm going to divide by 5. Does 5 divide 625 doing the calculator? How many times?
125.
125. And then does 5 divide 125? You told me.
25.
And then does 5 divide 5?
5.
5. And then 5 divides 5, 1? Is that it?
Yes.
625 is 1, 2, 3, 4 of these. Or 5 to the 4 power. Okay, these are all the same. So if 5 to the x plus 1 equals 5 to the 4 power, since I know that they're matching, these can go away, right? So x plus 1 is 4. Then you tell me the next step.
Minus 1.
Okay. And these are gone. What's left over?
3.
Does that make sense for number 22? I'm going to do 2 more of these guys. Yes?
Yes.
Do 2 more of these things. If I can do 2 more of these things, you get them, then we'll be okay. All right. So let me do one more like 22. 2.779999. Let's say 2 to the x plus 8 equals 16. All right, so 16, 2 divides 16, 8, 2 divides 8, 4, 2 divides 4, 2, 2 divides that 1. 1, 2, 3, 4. So 16 is 1, 2, 3, 4. 16 is 2 to the 4 power. So this one is that one. Is that okay? 2 times 2 is 4, 2 is 8, 2 is 16. So now.
Stand the back, please, okay? Listen to me.
Mute it. I'm hearing all this stuff coming in. Thank you. All right. So now you have x plus 8 is 4. Now answer it. What do I do? Subtract from both sides.
Minus 8.
A little bit, baby. No, she just left to.
Hello. Hey, mute your machines. I hear all this other stuff coming in. Thanks.
Well, she's opening up her own shop, so she went with them to go finish.
The person opening the shop. Can you mute it? Thanks. Thank you. All right, go.
Lemonade, cucumber lemonade is probably our most popular one. We have wild berry, peach mango, and we have the tropical fiber.
Okay, well, give me the tropical. That's fine.
Okay, let me do that one. I trust you. No, I'll be back Friday and Saturday.
Okay.
Hey.
Man,
All right, go ahead. Go ahead and mute your machines. I hear too much stuff coming in. Mute it. Mute it.
I will go walk and then it was rain. Did it rain over here?
No, we didn't. I know this morning when I took the kids to school, it was drizzling just a little.
I went outside to work on the yard. I said, I'm gonna go walk this. Oh, it's wet outside. So I said, let me start pulling out the weeds. As soon as I started pulling out the weeds, it started coming down.
It was pouring.
Huh?
It was pouring down.
Hello? Can you hear me?
Why
Yeah. Can you mute it? Thanks. There you go. All right, thanks. You muted it. Thanks. Bye. All right. So give me the answer.
Negative 4.
-4. All right, finally. Yay. Can I do one more like this? And then after that, you can go get your lemonades and cut the grass and stuff. Okay? All right, let me do it. How about this one? 2 to the x plus 1 is, I don't know, easy number, 8. We can do that one super fast. Watch. Well, I know that's going to be 2 to the 3, right? 2 times 2 is 4, 2 is 8. Let me just do it real quick just to make sure it's right. 2, 2, 2. 2 times 2 is 4, 2 is 8. Yeah, so 2 to the 3. I know these are all the same. So 2 to the x plus 1 equals 2 to the 3. For sure, I know that the numbers can go away, right? I know that these guys are gone. So x plus 1 is 3. And then you tell me, what do you do?
Minus 1 on both sides.
One on both sides. And go -1, -1. So x must be what number?
2.
2. All right. So that's what you're gonna need to do for my math lab. Okay. We're looking at test number 2. I want you to do number 19 and number 22. Yeah, this one. Number 22. Those two right there. Okay. So you're gonna do number 19 and number 22 from test number 2. Because we did a bunch of examples of those, so you should be okay. All right. Anybody any questions, anything?
What problems did we do on Monday?
I don't remember. I thought it was 16 and 20.
Okay,
Let
thank
me,
you.
let me look it up real quick. Yeah,
Okay.
it was this one. It was number 16 and number 20. This is the Monday one.
Okay.
And then today, Wednesday, do those two right there. Okay, so Monday is this. And then same thing, test number 2.
Okay.
Number 2. Just do those. Okay.
Thank you.
Everybody okay? Yeah. All right. So I'm gonna go ahead and shut it off in 1 minute. I'm gonna turn off the Zoom land. Okay. So 1 minute, 30 seconds from now. All right. So I'm gonna turn it off in about 15 more seconds. Let me see. 12, 13. Got it.
So 19 and 22, correct?
Yeah, 19 and yeah, 19, 22. And then the old ones are 16, 20.
Gotcha.
Old ones, the new ones.
All righty. Thank you so much.
All right, man. I'll see y'all later, guys. See y'all on Monday. All right, guys. Monday.